Attention class. Today we're going to talk about base theory. Does anyone ever heard of base theory? No? Okay, let's imagine a scenario. You're just casually walking on the street and you came across a guy. Now, the question is this guy more likely to be a teacher or more likely to be a farmer? You may think, what a strange question, and plus, you didn't give us enough condition to determine whether this guy is a farmer or a teacher. So, back in a scenario, after a short conversation, you find out this guy loves reading, and he even got a bachelor's degree. So, back in the question, is this guy more likely to be a teacher or more likely to be a farmer? Teacher, you might say, since it fits the teacher more precisely. But since we are in a math class, we have to find out in a mathematical way. So let's draw a graph. Here, the square here means all the population of teachers and farmers combined. And according to the statistic carried out by Executive Yuan, the ratio of teacher to farmer is 1 to 10. So 1 to 10 up here. The left-hand part, let's say teacher, T for teacher. Okay? And the right-hand part, F, since F for farmer. And what percentage of teacher loves reading? Let's say 80%. Okay? 80% here. The white area is those who are teacher and loves reading. Let's say art for reading. What about farmer? It's like about 30%. Okay, so right here, 30%. Now, what we're gonna ask is the probability of teacher given loves reading. So, to find out this question, we have to first calculate the probability of teacher that loves reading is equal to 1 out of 11 times 80%. And this is equal to 0.07 approximately. And the probability of those who are farmers and love reading is 10 divided by 11 times 30%. And this is equal to 0.27. I believe those smart ones have already come up with the result. But since others don't, we have to keep going. So the final question we're asking about is teacher that given loves reading equals to 0.07 divided by 0.07 plus 0.27. And this equals to 21%. What does this 21% mean? That means only 1 in 5 people that love reading are teachers. That's like a huge difference from we expected. But what makes our expectation wrong? Let's find out. So let's roll this equation more commonly. The probability of A given B equals to, wait a minute. Maybe I should lower this. The probability of A given B equals to the probability of A and B divided by the probability of B. What does this equal to? Since we don't know the probability of B, we know this after the calculation, so we extended it. The probability of P of A times probability of B B given A. And the denominator is P of A times PB given A plus the P of not A. In this case, the P of not A is the probability of being a farmer times the P of B given not A. Okay. So what does this equation tell us about? This equation tells us about that this is the prior probability. And since we know the condition, we have to put a new factor here. But most of us only think about this, the probability of B given A. In this case, is the probability that loves reading given he's a teacher, okay? But the condition isn't always true. See, the denominator here is even larger since the probability of not A is even larger than the probability of A. So what we think is true is not always to be. The condition only updates our expectation. So that's the heart of the Bayes theory. And the part right here is what we know as Bayes theory. Okay, and it is part of the Bayes theory. But I don't want you guys to memorize this. Instead, I want you guys to remember this graph here. Since this graph gives you a more visible way to understand the concept behind the Bayes theory. See, the ratio between farmer and teacher and those who love reading, right? This is a more directed and easier way to comprehend. But since we live in a country where judge students by only test and score, we have to do some calculations. So now the question is, there is a virus spreading among the country, and about 2% of the people are affected by the virus. And now, today the country invented a new test to find out whether the person is affected or not. And let's say if an affected person taking the test, it will have a 97% to be positive, which means he's affected. Let's say is writing in a mathematical way. The probability of positive, let's say POSE, given that it's infected, they just use INF, equals to 97%. And those who are not affected by the virus taking the test, it will still have about 9% of the probability to give out a positive result. So it's P positive. And given that it's not affected, it's about 9%. So today, you're taking the result and today you're taking the test and the result is a positive. So given positive. How likely are you really be affected? Let's say P of affected, given that you are positive result. Okay, so according to the formula here, actually the lower body, the probability of infected person given that his result is positive equals to the probability of being affected, 2%, times 0.97, and the denominator is times 7 plus. Those who don't, but still giving a positive result. 0.98 times 0.09. And this equation, according to our calculation, yields to 80%. Not even 50%. It's way large difference between the 50%. What does this tell us about? If you are taking the test and the result is positive, it doesn't tell anything about you are being affected or not. see only 80% of accuracy. Many people may take the test and the result is positive, so he spent all his money just to cure the disease he doesn't have, or even began to settle his own affair. This is really ridiculous. So before making any decision, always remember to think twice, okay? Think twice. Use mathematical methods. But what about other cases? What are the other situations that base theory becoming handy? Let's say Indonesia. Most of the Indonesians are Muslim, right? The Indonesians you see on the street are more likely to be a Muslim, right? And in fact, about 80% of the Indonesian population are Muslim. But since Indonesia are Muslim, would you say all the Muslims are Indonesian? No, of course not. That's because we know the global population right now is about 8 billion. And the population of Indonesia is like 270 million, sorry. I didn't mean that it's a little number, but compared to global population, that's not worth a mention. Okay. The other case is, what about COVID? Glad we all survived COVID. Do you guys getting vaccinated? Do you guys ever get vaccinated? At least I do, and I believe most of you do. But according to the statistic, most of the confirmed cases are vaccinated. Does this mean getting vaccinated make you more likely to get COVID or infected by COVID? Of course not. This is the opposite purpose of getting vaccinated. But why? What makes most of the confirmed cases are vaccinated? That's because the population of getting vaccinated is way more than the population of not getting vaccinated. According to the statistic, about 95% of the Taiwan population are getting vaccinated. So yeah, hope those who don't die because of COVID. Okay. And at the end of this class, what we learned today, we learned about Bayes theory. The Bayes theory formula right here, and the heart of Bayes theory. But I don't want you guys to memorize this once again. I want you guys to remember this, okay? The graph right here, since it gives a more visible way and an easier way to comprehend the concept behind the Bayes theory. And most importantly, another thing is a lifetime advice. Always remember to think twice before making any crucial decision and use mathematical method to prove your point. That's it for today. See you tomorrow.